All right, we're starting standard number 3, which is all about parallel and perpendicular lines. So for now, we're going to focus on parallel lines, but to do that, we have to know how to compare lines to see if they're parallel. So we have to know what's the important part that we're looking at, and that's the slope. We're looking at the slope. If both lines are tilted at the same angle, then they're parallel, and that tilt is the slope. And the slope in this formula is m. So hopefully you recognize y equals mx plus b from last year in algebra, because that is the equation for a line, where m is equal to the slope and b is equal to the y-intercept. It's really all going to come down to these two things in this standard. So I'm going to focus on the slope for today. You have to be able to look at an equation and know what the slope is. Or you have to look at a graph and figure out what the slope is. Or you have to look at 2 points and figure out what is the slope between those 2 points. If I were to connect these 2 points that I was just given, what is the slope of that line? Right now we're going to focus on an equation. I'll just give you an easy one to start. Y equals 3x plus 2. Slope is 3. Slope is always the number that goes with x. It's always the coefficient of x, as long as it's y equals mx plus b form. So what I mean is, as long as the y is all by itself on one side of the equation, then 3 is the slope. So 3 is the slope for that one. Easy enough. This is where it starts to get a little bit more difficult with an equation, is if you have it in what's called standard form, which basically just means all jumbled up. So say you have 3x plus y equals 6. Now, if I were to ask you what is the slope, a lot of people would say 3 because it's the number in front of x. And you would be incorrect, because it is not in the form y equals mx plus b. All right, before you tell me what the slope is, you have to have y all by itself. That means we got to get the 3x to the other side. It's got to go. So it's a term that's a positive term. So positive terms have to be subtracted to the other side. So we're going to subtract 3x to the other side, and we'll end up with 6 minus 3x. Now we have y all by itself. That's the key, getting y all by itself. Another common mistake is that people are used to seeing the slope come first and the y-intercept second. That doesn't matter which one comes first or which one comes second, like this here, for example. It's the number that is the coefficient of x. It's the number that's with x is your slope. M and x always go together. B is the constant. That's the one that's by itself. It doesn't matter if it's y equals negative 3x plus 6. These mean the exact same thing. All right, this is a negative 3 slope because it's the number in front of x. This is also a negative 3 slope because it's the number in front of x. This would be the y-intercept, positive 6, y-intercept, positive 6. Here's a common mistake. People want to have the slope come first because that's the way you're used to seeing it. So they'll just switch them and say y equals 3x minus 6. So they're like, I didn't change anything. It's still a minus sign. I just switched them so the slope comes first because I like it that way better. But what you did was you turned your slope into a positive number and you turned your y-intercept into a negative number. So you changed the whole thing up. Don't do that. You can switch them and make the slope come first, but you got to keep the sign in front of it with it. So this has to stay a negative 3x, and that has to stay a positive 6. So this is what the work, or some of the work today is going to be like, is going to be taking an equation that's jumbled up, where the y is not by itself, getting the y by itself, and telling me what the slope is. Okay, here's where you might have a second step to a problem like this. I'll do pretty much the same problem I just did, 3x plus 2y, but now I'm adding a coefficient in front of the y. So now it's a two-step problem to figure out what the slope is. Same thing as last time. You want to get the y all by itself, so you get the term that's not with the y over there first. And the term that it doesn't have a y in it is 3x. It's a positive 3x. We're going to subtract it to the other side. So you end up with 2y is equal to 6 minus 3x. So far, just like we did before, you might say, okay, the y is by itself, and I would say, not exactly. It still has a 2 in front of it. It has a coefficient that's not 1, and that's not good. So we have to get rid of this 2 as well. And how do you separate a coefficient from a variable? You divide it to the other side, because this is saying 2 times y. And when you move things to the other side, you have to do the opposite. So if this is multiplying, we have to divide. And when you divide to the other side, you divide it underneath every term. And we have 2 terms over here. We have a 6 and we have a negative 3x. So you have to divide 2 by both of those. Now you have y by itself. 6 divided by 2 is 3. 3 divided by 2 is just 3 over 2, or 1.5. It doesn't reduce. And when it comes to slope, it's better to keep it in fraction form as opposed to a decimal, because this tells you how far up to go and how far over to go. Remember that term, rise over run? That's another way to say slope, rise over run. If you just say it's 1.5, it's harder to tell, well, how do I get from one point to the next? How far up am I going and how far over am I going? Whereas if you keep it a fraction, you know you have to go up 3 and over 2. So just keep it as a fraction and reduce it all the way. That's already reduced all the way. You can't reduce 3 over 2 any farther. So we'll leave it like that. And if I gave you this problem on a quiz or a homework or a test and asked you to tell me what the slope is, you would tell me it's negative 3/2. All right. I think that's probably enough for day 1. So I'm going to end it there. If I decide that, well, let's just end it there. That's a good place to start. The whole parallel and perpendicular lines is based around the slope. You got to be able to recognize the slope of a line, and once you can do that, it's easy to tell if they're parallel or perpendicular. So let's keep it basic for day 1 and just figure out what the slope is from an equation that's all jumbled up. Get the y by itself. That's the lesson for the day. Get the y by itself, and the slope will magically appear as the coefficient of x.